Hello everyone. Today, I'll be explaining the concept of an API gateway, a central architectural component in modern distributed systems. In simple terms, an API gateway is a single entry point that sits between clients and backend services. It receives client requests, applies security checks and policies, routes them to the right microservice, and returns the final response. In a world where applications are built using dozens or even hundreds of microservices, the API gateway becomes the control center that manages and organizes all API traffic efficiently. Before microservices, monolithic systems exposed a single API endpoint. But with microservices, each service, like authentication, payment, or inventory, exposes its own API. This quickly becomes unmanageable for clients, which would need to know multiple URLs, handle multiple authentications, and coordinate versioning differences. The API gateway solves this by providing a unified entry point. Clients make just one call to the gateway, and it handles routing, aggregation, and security behind the scenes. This not only simplifies client code but also isolates internal microservice changes from the external world. Internally, the gateway operates through several layers. First, it receives the client's request and performs authentication, verifying tokens such as JWT or OAuth credentials. Next, routing logic determines which microservice should handle that specific request. If the request or response needs transformed, for example, converting JSON to XML or adding standard headers, the gateway performs that automatically. Finally, if the operation depends on multiple services, the gateway aggregates the responses and delivers a single, unified result to the client. This architecture keeps client interactions efficient and consistent. This diagram from Microsoft Azure shows how an API gateway works. Clients send requests, which are first authenticated and authorized. Then, the gateway routes each request to the right backend service, Service A or Service B, and may aggregate responses before sending them back. It also performs TLS operations, caching, and logs important metrics for monitoring. An API gateway's strength lies in its ability to centralize key operational concerns. Authentication ensures that only authorized users can access protected endpoints. Rate limiting and throttling prevent denial of service situations by capping the number of allowed requests. Caching improves performance by serving responses instantly. Load balancing distributes traffic evenly across multiple backend instances, keeping the system stable under high load. Finally, gateways continuously monitor and log API metrics, such as latency, error rate, and throughput, which helps developers diagnose issues and improve system performance. In practice, API gateways are available in both open-source and managed forms. Kong is a popular open-source solution built on Jinx that allows plugin-based extensions for authentication, caching, or monitoring. Amazon API Gateway is a cloud-native service that integrates tightly with AWS Lambda for serverless deployments. Apigee, by Google Cloud, focuses on enterprise-grade management, giving analytics, monetization, and developer portals. Even traditional Jinx can function as a lightweight API gateway when configured as a reverse proxy with routing and caching policies. It's important not to confuse an API gateway with a traditional load balancer. While both manage traffic, a load balancer operates at the network level, simply distributing requests among available servers. The API gateway works at the application layer. It understands HTTP methods, validates tokens, modifies payloads, and applies business rules. Essentially, the gateway is a smarter, more context-aware controller designed specifically for APIs. Like any architectural pattern, the API gateway offers major advantages but also introduces challenges. It simplifies client logic, centralizes security and monitoring, and helps scale microservices independently. However, since all traffic passes through the gateway, it can become a single point of failure unless properly replicated. Also, every additional hop adds some latency, so optimizing caching and routing is essential. Managing versioning and compatibility across services is another ongoing challenge for architects. In conclusion, the API Gateway has become a critical component in microservice architecture. It provides a single, secure, and intelligent entry point for all client requests, ensuring that communication between services is seamless, consistent, and protected. Whether implemented through open-source tools like Kong or managed solutions like AWS Gateway, this technology is what keeps modern API ecosystems organized, scalable, and reliable. Thank you.